right, good morning, everybody. So, today we want to talk about how to prove Stokes' law or how to show Stokes' law. Now, Stokes' law states that the viscous drag F, all right, so you have F, okay, is directly proportional to the coefficient of viscosity eta. So, you have eta here, all right, the radius of the drop R, okay, and the terminal velocity. So, you have what? V, okay. Now, this is the mathematical expression of what Stokes' law talks about. Okay, viscous drag F is direct proportional to the equation of viscosity, the radius, and the terminal velocity. So now, anytime you have a proportion like this, the first thing to do is to what? Introduce a constant of proportion. So you have F is equal to K, all right, eta, then R, then terminal velocity. Now, from this, what we are going to do is to what? Is to put an unknown exponent or unknown power on that on that on this particular variable. So we have F is equal to K. All right, this is a constant, so we have eta. We can say eta raised to power x. Okay, this is what r raised to power y, and terminal velocity raised to power what? Raised to power z. Okay, so this is what we are going to be having. Then we are going to find the dimension of each of the quantities. Okay, looking at it now, F here is what? Is MLT minus 2. The dimension of force is what? MLT minus 2 is equal to K. What is the dimension of viscosity? Viscosity is what? Is ML minus 1 and T minus 1. So you can put ML minus 1, T minus 1. Alright, then because there is a value of X here, you put what? X there. Then times, this is radius. The dimension of radius is length. So you have L raised to power, so you put what? Y here. The dimension of velocity, terminal velocity is what? LT minus what? Minus 1. Then you put what? Everything into what? Into Z. Now, if this is the case, so you use the exponent to open the bracket. So you have MLT minus 2 is equal to K. So if X is coming inside, we have M raised to power X. All right, L raised to power minus X, T raised to power minus X dot L raised to power Y, L raised to power, if Z is coming, that is raised to power Z, and T raised to power minus Z. So from this now, we can continue to have what? ML, this is the left hand side, minus 2 is equal to this K. All right, so we have what? M raised to power what? X. We have only one M dot what? L raised to power. How many L do we have? We have 3L. We have L raised to power minus X dot L raised to power Y dot L raised to power Z. Okay, then what is left? We have T what? We have T power minus X dot what? T power what? Minus Z. So I've just collected the like term. All right, so from that end, what we have what? MLT power minus 2, all right, is equal to, so we have constant, all right, M raised to power X. So if you use indices, now our constant in Stokes' law is going to give us 6 pi, all right, at the end of the day. So we have K is equal to 6 pi. This is the constant in Stokes' law. So that is, this K is going to be subtracted as 6 pi at the end of the day. So we have M raised to power X dot what? L raised to power what? Minus X. This is plus what? Plus Y. Then plus what? Plus Z. Okay, dot what? T raised to power what? Minus X, then minus Z. Plus going to minus is minus. Okay, from that place now, we can now see we have MLT minus 2 is equal to K. All right, now if you balance this what? 1, right? This 1, and this one is minus 2. So if you balance 1, all right, M here and what? M here, that is what? M raised to power 1 is equal to what? M raised to power what? X. So we are comparing it. So M is going to cancel M, then 1 is equal to what? X, or what? L is equal to what? 1. All right, then now if you look at what the value of L is power 1 here, while L is what? Raised to power minus X plus Y plus Z. So we can say comparing L, so we have what? L raised to power what? L raised to power 1 at the left hand side is equal to what? L raised to power what? Minus X plus what? Y plus what? Z. This one has cancelled. What is left? 1 is equal to what? Minus X plus what? Plus Y plus what? Plus Z. So this forms an equation. So we can call it equation 2, when this one is more like equation 1. All right. So moving on, if you compare T now, what is T? T raised to power what? Minus 2. All right. Here is equal to what? T raised to power what? Minus X, then minus Z. So T cancel what? T. What is left? Minus 2 is equal to what? Minus X minus what? Minus Z. All right, so if T is equal to minus 2 minus Z, then we have minus 2 is equal to, what is X? X was 1. All right, so we have minus 1 minus Z. All right, then if that is the case, if minus 1 cross to the other side, that is minus 2 plus 1 is equal to z. All right, now, okay, it's equal to minus z because minus is here. What's minus 2 plus 1? That is minus 1 is equal to what? Minus what? Z. Minus cancel minus. What is z? Z is equal to what? 1 as well. All right, so it means that for the values we are finding, x is equal to 1 and z is equal to what? 1. Now, for the value of x now, what is going to happen? For x, all right, now we had an equation here. 1, let's bring that equation out. 1 is equal to what? Minus what? X plus what? Plus y plus what? Z. That is when we compared what? When we compared L. So what are we going to be having? We are going to be having what? Um, we are going to be having 1 is equal to, all right? All right, so if you put the value of x here, all right, you are going to be having minus 1 plus y plus z. So what is z? Z is plus 1. Okay. All right, so what are we going to be having? This minus 1, all right, plus y plus z. Z is plus 1. If you move the value of 1 here, you have what? 1 plus 1 is equal to y plus 1. 1 plus 1 is 2, is equal to y plus 1. If 1 moves to the other side, that is 2 minus 1 is equal to y, or y is equal to 1. All right, that means all the whole values, all right, are 1. X is equal to 1, y is equal to 1, and z is equal to 1. All right, that implies that our equation, if you bring back this equation, all right, so what we said, the viscous drag F is proportional to the what? To the viscosity eta. All right, then what is the next thing? The radius r, the what? Terminal velocity what? V. Okay, then we said F is equal to what? K eta r and what? And V. So that means F is equal to, what is K? K is what? Is 6 pi. That is now what? 6 pi eta r and what? And vt. So this what? Stokes what? Expression. So that is it. So F is equal to 6 pi eta r v. All right, terminal velocity is called Stokes law. F is the viscous drag F. Force, that's the force. Eta is the coefficient of viscosity. R is the radius. V is the terminal velocity. All right, so thanks for watching. Bye. God bless you.